Continuing with the topic, types of number, today we're going to look at factors and HCF. Starting with factors. A factor is a whole number that divides exactly into a number without a remainder. We can use factor pairs to help us find all of the factors. So for example, the factors of 10 are 1, 2, 5 and 10. They are all the numbers that we can divide into 10 exactly. So 10 divided by 5 is equal to 2, which means 5 is a factor. 10 divided by 2 is equal to 5, so 2 is also a factor. 3, for example, we can't divide 3 into 10 exactly, so that is why it is not a factor. So if we look at some examples, find all the factors of 42. Well, the easiest way to find all of the factors is to start by doing them in a logical order. So I always start with 1 and the number itself. So 1 and 42. They are our first factor pairing because 1 can divide into 42 and 42 can divide into 42. Then the next number we look at is 2. Does 2 go into 42? Well, because it's an even number, any value that is a unit digit of 0, 2, 4, 6 or 8 we know is an even number, and even numbers can be divided by 2 exactly. So if we do 42 divided by 2, it gives us 21. Next number to check is 3. Does 3 go into 42? Well, a quick way to decide if a number is divisible by 3 is by adding up the digits of the number. So 4 add 2 is 6. If the total is in the 3 times table, then we can say it's divisible by 3. So 4 add 2 is 6, that is in the 3 times tables, so 42 is divisible by 3. If you're not sure how many 3's go in, you can always do a bus stop. 42 divided by 3. How many 3's go into 4? There's 1, and then there's a remainder of 1. How many 3's go into 12? There's 4. So 3 goes into 42 14 times. That's our next factor pairing. Then, once we've checked 3, we can go on to 4. Does 4 go into 42? Well, 42 isn't in the 4 times tables, so it's not divisible by 4. Or we can see if 2 goes in an even number of times, then 4 will definitely go in. But because 2 goes in an odd number of times, we know 4 is not going to go in. Next, we're moving on to 5. Does 5 go in? Well, 5 is not in the 42 is not in the 5 times table, so 5 we can't divide by 5, and again we can just by looking at the number, if it ends in a 0 or a 5 we know it's divisible by 5. Well, 42 has a unit digit of a 2, so it's not divisible by 5. Then 6. Does 6 go into 42? Well, yes it does. 42 is in the 6 times tables, or 42 divided by 6 is equal to 7. So we can say if 3 goes in 14 times, 6 is going to go in half that amount. So 6 goes in 7 times. Then you ask yourself, does 7 go in? Well, we can see 7 is already listed as a factor in our list. So once you've come to a number that's already in your list, you have found all of the factors. So we can see here the factors of 42 are 1, 42, 2, 21, 3 and 14, 6 and 7. So there's 8 factors, 8 numbers that divide exactly into 42. So next, if we look at 72, so the first pairing is 1 and 72. The next pairing, again, 72 is an even number, so we can divide it by 2. How many 2's are in 72? There are 36. Can we divide it by 3? Well, 7 add 2 is 9, so 9 is in the 3 times table, so yes, we can divide it by 3. Again, if we're not sure, we can always do a bus stop. 72 divided by 3. How many 3's are in 7? There's 2, and then there's a remainder of 1. How many 3's are in 12? There's 4. So our factor pairing is 3 and 24. Then we ask, does 4 go in? Well, again, you can either do a bus stop, or you can say if 2 goes in 36 times, 4 is going to go in half that amount. So 4 is going to go in 18 times. But again, if you're ever unsure, you can always do a bus stop. With 72 divided by 4. 4 goes into 7 once, so the remainder of 3. 4 goes into 32 8 times. Does 5 go in? Well, 5, the 72 doesn't have a unit digit of a 0 or 5, so we know 5 cannot be divided into 72. Does 6 go in? Well, yes, 6 is in the 72 is in the 6 times tables, so we know that 6 times 12 is 72. Or again, we can use this maths fact here. If 3 goes in 24 times, 6 is going to go in half that amount. Does 7 go in? No, 7 isn't in 72 isn't in the 7 times tables. Again, if we did a bus stop, we would see it wouldn't go in exactly. 8. Is 72 in the 8 times tables? Yes, it is. 8 times 9 is 72, or 72 divided by 8 is 9. And again, we can use the fact this time. 4 goes in 18 times. So 8 is going to go in half that amount. Then you ask yourself, does 9 go in? Well, we can see 9 is already in our list, so we've found all of the factors. So this time we can see 72 has got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 factors. All of these numbers are factors of 72. They can all divide into 72 exactly. Final example then, 150. So, first pairing, 1 and 150. Next, does 2 go in? Well, if you're unsure what half of 150 is, do your bus stop. How many 2's in 1? 0, carry the 1. How many 2's in 15? 7, remainder 1. How many 2's in 10? 5. So our answer is 75. Next, does 3 win? Well, 1 add 5 is 6. Yeah, so 6 is in the 3 times table, so we can divide it by 3. 150 divided by 3 equals 50. And again, you could do a bus stop if you're unsure of that. Does 4 go in? Well, we can see 2 goes in an odd number of times, so 4 is not going to go in. Does 5 go in? Well, we know if a number has a unit digit of 0 or 5, it can be divided by 5. So 5 goes in 30 times. Again, you can do a bus stop for that if you need to. 150 divided by 5 is 30. Does 6 go in? Well, again, if you wanted to check with your bus stop, 150 divided by 6. 6 goes into 1 0 times, carry the 1. 6 goes into 15 twice. remainder 3, 6 goes into 30 5 times. So 6 goes in 25 times. And again, you could use the maths fact here. If 3 goes in 50 times, 6 is going to go in half of that amount. Does 7 go in? Well, again, if you wanted to check, you may know straight away that 7 doesn't go in. But if you wanted to check, you can always do your bus stop. How many 7s in 1? 0, carry the 1. How many 7s in 15? There's 2, remainder 1. How many 7s in 10? There's 1, remainder 3. So we can see that it doesn't go in exactly. That should be a 1 there. Okay, 8. Well, if 4 doesn't go in, 8 is not going to go in. 9. Okay, so if you wanted to check, does 9 go into 150? Again, you can do a bus stop. How many 9s in 1? 0. Carry the 1. How many 9s in 15? 1. Remainder 6. How many 9s are there in 60? Well, 9 times 6 is 54, so there's going to be 6 remainder 6. So we can see the 6 doesn't go in. Does 10 go in? Yes, it does. 150 divided by 10 is 15. Does 11 go in? Well, again, if you wanted to do your bus stop here to check if 11 goes in, 150 divided by 11. 11 goes into 1 0 times. 11 goes into 15 once, remainder 4. 11 goes into 40 3 times, and we're going to have a remainder of 7. So 11 doesn't go in. Does 12 go in? Well, we can see 6 goes in an odd number of times, so 12 isn't going to be, you're not going to be able to divide 150 by 12. 13 doesn't go in, 14 doesn't go in, and then 15 we can see is already in our list, so we have found all of the factors of 150. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. By working them out in factor pairs, it makes sure that we haven't missed any off our list. Moving on to the HCF. The HCF, also known as the highest common factor. HCF is the highest number that is the same and can be divided exactly into 2 or more numbers. To find the HCF, first thing you need to do is list all of the factors for each number and then look for the highest number that is the same in all of the lists. So some examples then. Find the HCF of 24 and 36. So if we start with 24, the factors of 24, always starting with the number itself, like we did with the examples for factors earlier. So it's going to be 1 and 24. Then we ask ourselves, does 2 go in? Well, yes, it's an even number. 24 divided by 2 is equal to 12. Then does 3 go in? Well, we know that it's in the 3 times table, so 24 can be divided by 3, which equals 8. Does 4 go in? Well, again, we know it's in the 4 times table, so it can be divided by 4. Or we can use the fact if 2 goes in 12 times, 4 is going to go in half that amount. So 24 divided by 4 is 6. Does 5 go in? Well, no, it doesn't divide by 5 because the unit digit is a 4. And then does 6 go in? Well, it's already in our list here, so we have found all of the factors of 24. Moving on to 36 then. So the first pairing is going to be 1 and 36. Second pairing, does 2 go in? Well, yes, it's an even number because we can see the unit digit is 6. So 36 divided by 2 is 18. Does 3 go in? Well, yeah, we know 36 is in the 3 times tables, or we can do our check. 3 add 6 is 9, which is in the 3 times tables. So yes, it can be divisible by 3, which equals 12. Does 4 go in? Yes, again, it's in the 4 times tables. 36 divided by 4 is 9, or 4 times 9 is 36, or we can half this here. If 2 goes in 18 times 4 is going to go in half that amount. Does 5 go in? No, it doesn't, because it's not ending in a 0 or 5. Does 6 go in? Yes, it does. 36 divided by 6, or 6 times 6 is 36. So we have now found them all. Well, if we look at our list, we can see there are a few factors, a few numbers which are common. 1 is in both, 2 is in both, 3 is in both, 4 is in both, 6 is in both, and 12 is in both. Well, HCF, we're looking for the highest common factor, so the highest number that appears in both of these lists is 12. So the HCF is equal to 12. And again, you may have known that straight away, but it's really important to show your workings and to how we've got the answer of 12. One final example then, the HCF of 60 and 45. So if we start with the factors of 60, we know it's going to be 1 and 60. Does 2 go in? Yep, you can divide 60 by 2. 60 divided by 2 is 30. Does 3 go in? Yes, it does. We can divide 60 by 3, because 6 divided by 3 is 2, so 60 divided by 3 is 20. Does 4 go in? Yes, it does. Again, you can either do a bus stop, or we can see that 2 goes in 30 times, so 4 is going to go in half that amount. Does 5 go in? Yes, it does, because it ends in a 0 here. 5 times what gives you 60, or how many 5s are there in 60? Well, there are 12, so it's 5 and 12. Does 6 go in? Yes, it does. Again, we can use this fact. If 3 goes in 20 times, 6 goes in half that amount. So 6 and 10. Does 7 go in? No, it doesn't. Does 8 go in? Well, we can look at the 4 here. 4 goes in an odd number of times, so 8 is not going to go in. Or if you did a bus stop, you would see you'd have a remainder. Does 9 go in? Well, no, 9 is not in, 60 is not in the 9 times tables, or similarly, we can do the same here and add these up. 6 add 0 is 6. That's not in the 9 times table, so it's not divisible by 9. And then does 10 go in? Yes, it does. It's already in our list, so we found them all. Moving on to 45 then. So the first pairing for 45 is going to be 1 and 45. This time does 2 go in? Well, we can see it's an odd number because it's got a unit digit of a 5, so 2 is not going to go in. Does 3 go in? Well, 4 add 5 is 15. 15 is in the 3 times table, so yes, it's divisible by 3. If you're not sure how many times, remember you can do your bus stop. 45 divided by 3. 3 goes into 4 once, remainder 1. 3 goes into 15 5 times. So 45 divided by 3 is 15. Next, does 4 go in? Well, if 2 doesn't go in, 4 is not going to be able to divide in. And then 5, well, yes, we can see the value ends in a 5, or as a unit digit of a 5, so we know it can be divided by 5. How many 5s are in 45? Well, there are 9. Does 6 go in? No, we can't divide 45 by 6. Does 7 go in? No, again, it's not in the 7 times table. That's a quick way to check. 8. Well, if 2 and 4 haven't gone in, 8 is not going to be able to divide into 45. And then 9. Does 9 go in? Yes, it does. And it's already in our list here, which means we've found all of the factors. So, now to decide what the HCF is. Looking at our list, we can see that 1 is the same, 3 is the same, 5 is the same, and 15 is the same. So the HCF, the highest common factor, the highest number that divides both into 60 and 45 is going to be 15. And then if we just write that here, HCF equals 15.